रेडी है सर।
अच्छा बस ये हो गया बस।
ठीक है।
बिस्मिल्लाहिर्रहमानिर्रहीम। पिछले 2 लेक्चर जो हमारे लाइव हुए हैं, अनफॉर्चुनेटली कोरोना की वजह से हमें ऑनलाइन टीचिंग की तरफ आना पड़ा, और इसके लिए आपको याद है we left at integrating at the differentiation of vectors, and then we were talking about the operator del. Now today I'll solve 2-3 examples in that regard. The first example I have written on the board, which contains 2 parts, A and B. Here he says find del of f, where f is a scalar. It means you have to find the gradient of f, and where in first case f is this quantity, that is with positive 1 over 2. In the second case it is with negative minus 1 over 2. Okay? So solution is something like this. Now please note, if you have any problem, then you can contact me on WhatsApp on this number. Okay? I will be doing everything in detail. But anyway, if you have some problems, you can always write me a WhatsApp message. You will get definite answer. Maybe not immediately, but after some time. Okay. Now, as far as the first part is concerned, f is this quantity. So this is operating on this, then this will operate on that, this will operate on this will operate on that. So this is 3 parts. And look, there is a symmetry. This is differentiation with respect to x, this is with respect to y of the same quantity, this is differentiation of same quantity with respect to z. I will just take only one of them. Okay? For example, delta over delta x of x square plus y square plus z square raised to the power 1 over 2 is equal to 1 over 2 x square plus y square plus z square 1 over 2 minus 1 into derivative of this, because this is partial differentiation with respect to x, that is 2x. And you can cancel it, and your result will be x, and see here minus 1 over 2 will be left here, which will go into denominator, and it will be x square plus y square plus z square raised to the power 1 over 2. Now you can tell me the answer of this. This will be y over the same quantity, and this will be z over the same quantity. So this expression will give you y over x square plus y square plus z square. You see, I haven't calculated it in detail, but looking at the symmetry, I am writing the result. So you have to do the same thing, because you have to learn the shortcut technique, that is mathematical methods. That is y square plus z square raised to the power 1 over 2. Now put all that things here. Now if I put it here, then I have del f, gradient of f, is equal to this quantity, and that will be common. Okay, because these are added, this will be common, so you can say 1 over x square plus y square plus z square square root inside bracket, I, and delta over delta x mean x, this is common, plus j, delta over delta y is that thing, and this is common, y plus k z, and this this is our vector, divided by magnitude of r, that is r. So del f is equal to that quantity, and that is the answer of that. That is the first part. Now, we go to the second part of it. In second part, f is changed. It is with minus sign. So that is with minus sign. Okay? And I will now do the same process. Again, but with this minus sign. So look, again there is a symmetry. So I will only calculate the first one. Delta over delta x of x square plus y square plus z square minus 1 over 2 is equal to minus 1 over 2 x square plus y square plus z square minus 1 over 2 minus 1 into derivative of this, which is 2x, and that will give me minus x divided by this becomes 3 by 2. 3 by 2. This is x square plus y square plus z square 3 by 2. Now if you say, okay, what about if this operates on this, the answer will be, that is operation of this on that will give me minus y over x square plus y square plus z square 3 by 2, and of this will give me minus z over x square plus y square plus z square 3 by 2. Now the next thing is to add them. Okay, so del f, where f is now this, is equal to, and this will become vector quantity. You see, the first is also vector. Vector divided by its magnitude, which is a vector. And this is a unit vector. I told you last time in the class that del f is gradient of f, and it represents a normal to the surface, and therefore this is normal n. Okay? Now, in this second case we were talking about, again this thing is common. This is out 1 over x square plus y square plus z square 3 by 2, minus it with everyone, sorry, this one there, and therefore minus is common. Inside you will be having x and of course I, because I is there, so xi plus yj plus zk, and this is r, this is r cube, because r raised to the power 1 over 2 is, sorry, x square plus y square plus z square raised to 1 over 2 is r, and this is r cube. So this is r vector with minus sign divided by r cube. Okay, so that is the answer of the second part. Okay, that is the second part of that. Now, that is one question we have completed. If you remember, when we were leaving, then I gave you a home assignment in written form, and for assignment number 1, which was the first part, you have to submit it by 4th December 2020, and you see we have completed all the 8 questions. Okay, the material for all the 8 questions. You can easily submit it by 4 because still there are 2 days left. You can work on it. As far as the remaining assignment, that is question number 9 to 17 are concerned, no, you see that we have only covered material for 5 questions, and then 3 questions are left, and will be slowly developing that as well. Okay, so that is look at your assignment, and now you will be able to do assignment very easily. Okay, now we come to another question, and it will help you to start with your assignment. And this says that if this is again an example, if phi is equal to xy plus yz plus zk, xz, and a is equal to x square yi plus y square zj plus z square xk, find a del dot phi, b phi del dot a, c del phi cross a at the point (3, -1 and 2). Now, before I take this problem, be careful. Okay, some people, what they do, they first put these values there and then they solve the question. That's wrong. First you have to solve it for the problem, and at the end you put these values for the point. Okay? Let me take the first case. A dot is vector, del phi is a vector. So two vectors are multiplied together through dot. Okay? So phi is this quantity, which is scalar quantity. You can't see any unit vector with that. A is a vector. You can see the unit vector with that. It makes it vectors. So what I am going to do, let's first find del phi. Now if you find del phi, then the value of del is and then there is no dot, because this is scalar, this is vector. You don't have to put any dot, otherwise it is wrong. Okay? So xy plus yz plus xz. Okay, this will operate on all these three. This will operate on all these three. This will operate on all these three. So if you do that, so I delta over delta x, xy plus yz plus xz, etc. Now, if it operates on this, then from first part you will get y, because it is partial differentiation with respect to x. So what you will get? You will get yi, because this is 1, this is 0, and this is x1 zi, so I is common, y plus z into I. This what you get of the operation of this on that. Second is this one. So this will plus j, derivative of y is 1, so we will get x. Derivative of y is that, you will get plus z. That's all. Because there is no y there, 0. This will operate on this. No z there. Z is 0. Z is here. Derivative is 1 y plus k into y plus 1, and that is x. So that is your del phi. And now you can dot it with A. A is that one. So A dot del phi is equal to x square yi plus y square zj plus z square xk. That is your A. Since it is a vector, and this is also a vector, del phi is also a vector, this is a dot between the two, y plus z I plus j x plus z plus k y plus x. Okay, dot. It means I dot I is 1, I dot j is 0, I dot k is 0. So first of all, this will give you the answer, but this will give you 0, and this will give you 0 as well, because you know already I dot I is 1, but I dot j is 0, and I dot k is 0. So I am writing it x square y into y plus z. That's it. Then this will be multiplying with this, with that, with that. J dot I is 0. You don't have to write. J dot j is 1, so you get y square z x plus z, and for last one plus you will be having z square x into y plus x. And you can open it. Okay, now you can put the values. He's saying, okay, find this, all these at this point. It means x is 3, y is minus 1, z is 2. So A dot then is x is 3, so 3 square into minus 1 plus 2 plus y square is minus 1 square into 2 into 3 is x, z is 2 plus z is 2 square, x is 3, y is minus 1 and x is 3. Calculate it. This is 1. It is 1 from here, minus 1, and 3 square is 9. So minus 9 from here. Then 2 plus 3 is 5, 10, minus 1 square is 1, so plus 10. Then 2 from here, 6 into 4, 24. So look, 34 minus 9. So answer is 35 with plus sign. This is a scalar quantity. It should be. Why? Because dot product of two vectors is scalar quantity. Now here in this case, you just try yourself how to do that, because it is simple. It is just like this. The only thing is that del was operating on phi, and now phi is outside the operator. So first you will find del dot A, just del dot A, which will be scalar quantity, and you will be multiplying another scalar quantity, this with that one. You try it yourself, because I have shown you the procedure. No problem. And you will see what is the answer. Okay, that is also scalar quantity multiplied by a scalar quantity, answer will be a scalar quantity. Okay? So that is one. As far as C part is concerned, that is del phi cross A. This is cross product of two vectors. That is, two vectors are being multiplied together through cross. So answer is a vector. So we know from the beginning that answer, unlike this, where the answer was scalar quantity, answer will be scalar quantity because scalar multiplied by scalar. And here it will be a vector quantity because it is a cross product of two vectors. And the direction of the product vector will be perpendicular to the plane which contains del phi and A. Okay. Now we have already find del phi in this expression and A is there. So we will use the result of this A part because that is del phi we have already calculated. There is no need to calculate it again. So I can write it like this: y plus z I plus x plus z j plus x plus y k. That is your del phi which we have calculated in part first. Then cross A, which is given up there in the problem, x square y I plus y square zj plus z square x k. You know, the cross product is, it is obtained with the help of determinant. So we'll say, okay, that is the determinant, ijk, y plus z here, you know the procedure, x plus z, x plus y, this is here, x square y, wait a minute, this is y square z, yes, y square z, y square z, z square x. You know how to open the determinant? I, this into this minus this into that, x plus z into z square x minus this into that, y square z into x plus y plus j. Then this into this is with minus sign because we are coming from the same direction. So y plus z into z square x minus x square y into x plus y plus k, alternatively if you are going from that direction. So you will be having k y square z into y plus z minus x square y into x plus z. And now you can put the values there. X is 3, z is 2, 2 square, x is 3. So if you put these values, what you will get? 2 and 3, 5, and this is 4 and 12. 12 into 5 is 60. Minus 1 square into 2, 3 minus 1. This gives you 2. 2 into 2 is 4. And this is 1. So minus 4. Minus j. Similarly, you put values there. you put values there, right? And you answer it. I'm writing the answer because next is just the empty job. So you will have a vector that is 56i plus something, minus something, plus something, etc. So this is a vector quantity. So this was example number 2. So having done with that,